So this question is about using vectors in kinematics. So we've got a particle starts from a point with position vector 3I at 7j meters and moves with constant velocity 2I take j meters per second. Find the position vector of the particle 4 seconds later and find the time at which the particle is due east of the origin. So to find the position vector of the particle after 4 seconds, we're going to use the formula R is equal to R0 plus Vt. This works for constant acceleration. R0 is where it starts from, which is 3I add 7j. The velocity is 2I subtract j, and it's 4 seconds, so that gets times by 4. So all we need to do is multiply all this out. So we're going to get 3I add 7j, add 8I take 4j, and then just simplify it. So 11I add 3j meters. And that's it for part A. Part B, we're going to find the time at which the particle is due east of the origin. So to start with, if we get a general form, just having a cat interrupting. Hello, Pi. If we get a general form for the position of the particle at time t, so using the same formula, we're going to get R is 3I add 7j plus velocity V, which is 2I take j times t. So if we expand all that and group the i's together and j's together, we're going to get 3 plus 2t times I, and then we're going to get 7 take t times j. So it's going to be moving due east when the j component is 0. So if you're going due east, that's where you're moving in this direction. So that means that there's no vertical component to the motion. So in other words, this bit is 0. So along here is I, that's this part, going up 0, so j is 0 in other words. So we're going to solve 7 take t equals 0, so therefore t is equal to 7 seconds, and then that's our answer.